Okay, I apologize if this slide sounds a little distorted. I actually had to record this slide separately because there was an error in the initial recording, and then I've gone back and added this slide in. So what we're seeing here is called a spirograph or a spirographic readout, and this is going to be showing us the different volumes or capacities, basically the different levels of air, the different measurements of air in different types of breathing within the lungs. Now, the numbers here, the actual volumes, we don't need to know that for lecture. I want you to know what each of these names that we're going to be talking about represents. For example, if I ask you about tidal volume, I want you to know what tidal volume means more so than what is the measurement of tidal volume. Now in lab, there are going to be some volumes that you need to know. So there is some overlap here between lecture and lab, and then there are some things that you need to know more for lecture versus more for lab. So let's go ahead and look to see what this is showing us and how we obtain it. Now, up here at the top, this is how we obtain it. There is this device that the patient is breathing into, and it's going to measure the volume of air blown out or breathed in. And then once that's been done, we get a readout that looks like this down here at the bottom. Now, there's different types of breathing, which we can see by the different types and sizes of waves in this readout. Now, when you're just normal, quiet breathing, so that's a phrase that we're going to hear a lot this chapter, normal, quiet breathing, which is just your regular inhale, exhale without really thinking about it. And that's what we see here in this yellow region. So we have our regular inhale and then our regular exhale. And that volume here, represented by the yellow area, is called tidal volume. And tidal volume is just the volume of air either inhaled or exhaled. So it's the volume of air moved in one quiet inhale or one quiet exhale. Tidal volume, normal quiet breathing. The volume of air moved in one tidal inhale, quiet inhale, or one tidal exhale, quiet exhale. Now, let's say you breathe in a normal breath and then you breathe out a normal breath. So that inhale was a tidal volume inhale. The exhale was a tidal volume exhale. There's still quite a bit of air left in your lungs. So after your normal tidal exhale, starting from that point, let's breathe out more. Let's breathe out as much as we can. So that's this area here in kind of this dark blue area. And this is called the expiratory reserve volume. So the expiratory reserve volume is the volume of air that can be exhaled forcibly after a normal, quiet, or tidal exhale. It does not count the tidal exhale itself. It is only the amount of air that we can exhale forcefully after a normal tidal exhale. So now we see we breathe in again. And now we're back to our normal tidal inhale, tidal exhale. Tidal inhale, tidal exhale. Tidal inhale. So now once we've taken our normal tidal inhale, our lungs are not completely full. We could forcefully inhale quite a bit more. And that's what we see right here. So we've taken our normal tidal inhale, and from this point, we begin measuring. And we inhale as deeply as we can. And that's what this pink area here is showing us. This is called the inspiratory reserve volume. And the inspiratory reserve volume is the amount of air that we can forcefully inhale after a normal tidal or quiet inhale. Now, those are different volumes. When we're talking about capacities, capacities are when we add different volumes together. So let's see some different capacities. Let's exhale again. And now we're back to our normal tidal volumes. But let's inhale the normal tidal inhale plus the maximum inhale, so the inspiratory reserve volume. If we measure the tidal inhale plus the inspiratory reserve volume inhale, so the yellow plus the pink, that is called our inspiratory capacity. Inspiratory capacity is tidal volume plus inspiratory reserve volume. I'll say that again. Inspiratory capacity is tidal volume plus inspiratory reserve volume. It includes a regular quiet inhale plus the air that we can forcefully inhale. So right now, we're at the top of an inspiratory reserve volume inhale. Our lungs are maximally inflated. They are as full as we can make them without doing damage. Now from that point, let's say we blow all of the air out that we can possibly blow out. So we've blown out our inspiratory reserve volume, we've blown out our tidal volume, and we blow out our expiratory reserve volume. So that is all of the pink, it is all of the yellow, and it is all of the dark blue. That is called the vital capacity. Now, the vital capacity is going to have a few different definitions. First, it is inspiratory reserve volume plus tidal volume plus expiratory reserve volume. I'll say that again. Vital capacity is inspiratory reserve volume plus tidal volume plus expiratory reserve volume. Now, another way that we can define this vital capacity, it is all of the air that we are capable of moving. So you filled your lungs up as full as you can, and you breathe out as much as you possibly can. During that breathing out, that is blowing off your vital capacity. Now, if we take, let's see, which ones have we covered here? If we breathe out as much as we possibly can, so now our lungs are as deflated as we can make them. We've blown off all of the air that we can blow off. Well, our lungs do not deflate like an empty balloon. When we blow out all of the air that we can possibly blow out, there is still some air left in our lungs that we are unable to breathe out. And that's called it's called residual volume. The residual volume is the volume of air that remains in our lungs after maximum expiration. Residual volume is the volume of air that remains in our lungs after a maximum expiration. So, if we combine the expiratory reserve volume and the residual volume, that gives us functional residual capacity. Expiratory reserve volume plus residual volume is equal to functional residual capacity. So what is functional residual capacity? Functional residual capacity is the volume of air left in our lungs after a normal tidal or quiet exhale. So when you're just sitting around and you're breathing and you breathe in and then you breathe out, it includes the air that you could potentially breathe out and the air that you are incapable of breathing out. That is the functional residual capacity. And there's one more volume that we need to know. If we take all of the air that our lungs can hold, so let's say you breathe in as much as you possibly can. So right now, you are at this point. Your lungs are as inflated as you can make them. If we were to measure all of the air that is in your lungs, that is called the that is called the total lung capacity. Total lung capacity is how much air can your lungs hold? And we find that by adding the inspiratory reserve volume, I'll write IRV, plus tidal volume, TV, plus expiratory reserve volume, ERV, plus residual volume, RV. Sum that up. Total lung capacity is the volume of air that your lungs are capable of holding. Both the air that you can breathe out and the air that you cannot breathe out. It includes inspiratory reserve volume, IRV, tidal volume, TV, expiratory reserve volume, ERV, and residual volume, RV. Now, of all of these different volumes and capacities, it is tidal volume, normal, quiet breathing, that we are going to be most concerned with. So, coming up, we're going to start talking a little bit about tidal volume and some calculations that we can do with it.